Welcome to Study Loop.
First, we're going to fill in the blanks that are highlighted in the table. And for the degrees of freedom, that's the number of groups minus 1. That's for the degrees of freedom between. The degrees of freedom within is the total number of observations minus the number of groups. And the total degrees of freedom is the number of observations minus 1. The mean squares between is the SS between over the degrees of freedom between, and the mean squares within is the SS within over the degrees of freedom within, and the F ratio is the mean squared between over the mean squared within. So the degrees of freedom in the first row, the degrees of freedom between would be 56 minus 50, which is 6. The mean square between would be 31.1 over 6, which is 5.1833. The mean square within would be 50 over 50, which would be 1. The F ratio would be 5.1833 because it's 5.1833 divided by 1. And the sum of the squares within would be 50. All right, now on to part B. Since the degrees of freedom between is the number of groups minus 1, and the degrees of freedom between is 6, the number of restaurants would be 7. Since the degrees of freedom, the total degrees of freedom is the total number of observations minus 1, the total degrees of freedom is 56, the total number of customers would be 57. The critical value for an F distribution depends on the degrees of freedom and the significance level. And so for an alpha of 0.01 with 6 degrees of freedom between and 50 degrees of freedom within, we can find the critical value using an F table or software. And I get about 3.186. Since the calculated F value of 5.1833 is greater than the critical value, we reject the null hypothesis. The results of the ANOVA indicated that there was a statistically significant difference in a customer ratings among the 7 fast food chain restaurants. Would be an APA style. And then indicate F with the degrees of freedom equals 5 we'll call it 1.8, and P was less than 0.01. The affected size this this is the SS between over the SS total, so that's 31.1 over 90, which is 0.3456. And this means that about 34.56% of the variance in customer ratings can be attributed to the differences between the restaurants. W squared is the SS between minus the product of the degrees of freedom between and the mean squares within over the SS total plus the mean squares within. And so that's going to be 31.1 minus 6 times 1 over 90 plus 1, which is about 0.2758. And it means that about 27.58% of the variance of customer ratings can be attributed to difference between the restaurants after adjusting for the degrees of freedom. And W squared is smaller than N squared because W squared provides more unbiased estimate of the effect size. By adjusting for the degrees of freedom. N squared tends to overestimate the population effect size, especially in small samples.